When I started programming in C++, I learned using a library called SFML, which is like, if you've heard of Pygame, it's like Pygame, but for C++. And I'm sure it has other bindings, but that's not what I use. Now, using SFML over the years, I've made several things, from simulators to Conway's Game of Life to even a mock-up little 3D engine when I was first learning 3D graphics. Thanks, 3D Sage. They have a few modules, namely audio, network, system, graphics, and I'm not sure what the other one is right now, but it's not really important, as it's just stuff to make the other ones work. We already use the audio package, and that's how we have sound and music in the engine so far. So adding the network package just kind of seemed like the next logical step there. With this in mind, over the last few days I've added a few extra features to the engine, such as syncing position, rotation, scale, and even the texture of an object, as well as the rotation and the position of other players. But how did we do it? And with that, that kind of brings us to the point of today's video. Packets. Now, SFML actually makes network kind of simple. As long as you really just have a basic understanding of what an IP address is and a local versus an external IP address, then pretty much you'd be able to figure this out. And I rather like it since it gets rid of the most of the abstraction that a Unity netcode library would. I just found those hard to understand for some reason. I never really could. I got some working mock-ups with like Mirror or Fishnet, but it just seemed weird. I didn't really fully understand how it was working. So that led me back to the SFML package here. And since that's the beautiful thing about C++ is I can use whatever library I want, provided the license allows it. It fit right into the engine like a Lego piece. All we had to do was link it up, make sure SFML was properly linked statically, and then there we go. It's in the engine with the rest of it. The server uses a client to server to client architecture, meaning that everything the client does has to be sent to the server and then broadcasted out. This way, none of the clients actually truly talk to each other. They only talk to the server to maintain a sort of basis of anonymity there. And on top of that, it keeps people from doing silly things, just, like speed hacks or flight or something like that. Granted, I don't really have much sanity checking in that department yet. So, the general idea is the server is going to have a port and socket, and the client or clients are going to have a port and socket. The server's port has to be known in advance. In my case, I chose 9999 because it was just one I had already port forwarded from a prior experiment. But then you bind your port to a socket, and once the socket is bound, you pretty much can use that to send information back and forth over the internet. Here's where we hit our first choice we have to make. We have to choose either TCP or UDP. The main difference between them, since we're not going to get into the complete nitty-gritty details there, is that UDP will send a packet consistently, and it's not really going to care whether or not it makes it to its destination. It'll do it, it'll get it done, it'll do it quickly, but then that's the end of it. Once it leaves its door, it doesn't give a shit anymore. TCP, however, will take meticulous care of its package and make sure it makes it all the way to its destination. It may be a little bit slower, but it is for sure going to get there. I went with UDP just because, with position and stuff, I'm going to be sending it out so quickly that it doesn't matter if one is missed, because the next one is going to automatically hit on the position. And then the player's position will be updated in the engine, and there we go. So we have that covered, port 999 on UDP. We have that port forwarded in our router, and from that point on, the computers should be able to talk to each other. For the sake of the rest of the discussion, I'm going to act as though we're going over a LAN connection, even though it does both. On a LAN connection, we have this funky little feature called broadcast. We can actually create its own thread, and once every so long, I have it every 10 seconds, the thread will broadcast an IP address and port that you give it in. When a thread from a client picks up this broadcast message and it's running the same program, I have it set up to automatically bring the other person in without having to enter the IP address of the local connection. Now, how does it know what clients it has connected to? Well, every time a client connects to the server, once it does its initial handshake request, the server maintains two lists, a list of the client's ports and a list of the client's IDs. Technically, we have the lists together in a key pair, but for the sake of thought, we can keep them as separate lists. When a person sends a packet in, that packet brings their player ID with it, so we have some sort of tracking of who is sending what. When the server gets this packet with the player ID and the command in it, it will take note of the client port and the server address of everyone who is not that player ID, and it will ship it right on out to everyone. That way we don't get repeated messages back to the same person who sent it, which would be a little annoying with stuff like spawning an object. Someone would spawn two, inevitably. Okay, so we know how the information goes back and forth, but how do we get the information into the neat little packet? This is through a process called serialization, and the inverse of that would be deserialization when we pull it out of the packet. Again, SFML makes this really, really easy. For the packet, we would just create an instance of the packet class, SF packet, and then once the packet is made, we literally just, and I'll show a little graphic right here, we'll just use the angled brackets to insert them into the packet. We just take our variables from our object and we use our angled brackets here to insert them into the packet. The thing about packets is they have to be the exact same on the in as they are on the out. And I mean, that kind of makes sense. Anything you put into the envelope, you would want the person on the other end to pull out of the envelope. You know, if someone sent me a letter and the letter wasn't in the envelope by the time it got to me, I'd be a little peeved. This idea of a packet is literally just something to store a variable, something that will store a variable that can be passed over the internet. That is all it is. There's really nothing more to it. And really, that's it. I mean, you put the information into the packet. Now, on the receiving end, you would do the exact inverse. You would use the greater than symbol, and you would pull it out of the packet and put it back into local variables. Once you have those local variables, you can shove those into anywhere you want. I chose to make a little struct called object actions, which maintains a rotation or scale or texture ID, or really whatever I need to pass along at that time. We don't have to assign them all with every packet, as that would be a huge waste of network traffic, but we can assign the ones we need, and judging by just the type we put at the beginning of the method, we can extrapolate what data to pull out. From the rest of this on, it's just every time we want something to be broadcasted to every one of the clients, we just make sure we send one of these beautiful packets all the way back to our server. And once the server receives them, it parses the data, puts it into an object action section, and then upon the next frame, it reads that object actions list, and it will go through every single action that it received in the prior frame, and it will execute the broadcast. And with that, we have an engine that handles scale, rotation, texture, and everything else over the internet. And it was a hell of a lot easier than using any of Unity's netcode packages. As another brief overview, say the client wants to get something done. Now, the client has no idea that any of the other clients exist. It can't know that. The only person it can talk to is the server. The client would say it wants to move this object from position 1-1 to position 1-2. It would create a packet with the necessary information, and it would ship that off to the server address, because we know that server address being the client. The server would then take that information, handle it with whatever rules we have given it, and then it will broadcast that same message out to every client, since the server knows about everyone else. Now, say the server wants to get something done. The server just, sends itself a packet. It's really literally the same way. The server's just kind of this omnipresent thing in the background. It's even actually in its own thread, so we don't have any program blocking. That way it can be doing something, and the main program, the game engine itself, will not stutter or stall. At the end of this all here, I got a little fed up with how the little Robloxy guy looked, so we spent a little more time in Blender, and I came up with this little wizard fella, who he looks much better than the last guy. He's not great, but I've already set a texture up in the Atlas for him following his UV map. I figured out a new pipeline for getting these UV maps actually imported into my Atlas, and we can just create multiple colors of the same things. Kind of like a Four Swords adventure kind of deal. Now, I'm at the point in the engine where it's done. I gotta make something with it. So if anybody has any ideas on what I can make with it, my current thoughts are something like a 4-player Fall Guys kind of thing. I mean, it's got a simplified physics engine in it. That was one of the first things I made in it. I could totally make blocks that move dynamically and push you off as the colliders are updated every single frame. Make a checkpoint, make a beginning, start a race. It's already got a predefined level system. Its load objects method will only load objects from the folder named map 0, map 1, whatever the level number is. So really, I mean, that's kind of the direction I'm seeing. I don't know what else to do with it. So any thoughts would be appreciated. Thanks for listening to me ramble.